Well, let's shoot for like 45 minutes or something like that, and then we have some time for some cold beers or whatever.
1 beer.
1 beer, 2 beers. So first, a few questions to you. So you've all heard about cloud computing. So is this the next? Who thinks this is the next wave of IT? Raise your hand, please. Cloud computing, the next wave of IT. Okay. Right. Whoa. Who thinks it's a lot of marketing hype?
Is this an exclusive or?
Both. No. Does it say X or? Who thinks this is a lot of marketing hype?
Could be both.
Okay, well, raise your hand if you think so.
I think
So there's a lot of people who think nothing. Right? Well, I think you're both right. But for some reason I'm going to give you kind of the same talk as the other guys, but from a different perspective, and I will focus a little bit more on the why. And we'll focus a little bit more on the drivers that are a little bit more long term. So that whenever you get stuck into the nitty gritty of a daily decision, you can have some perspective and you go like, hey, are we fighting the previous war or are we fighting the next war? Because if you're fighting the previous war, then you're dead. And if you're fighting the next war, you stand a chance. And now I'll tell you a little bit about myself in a second. I've been working on this for a couple of years now, and in my perspective, it's not so much, it's both, really. There's a lot of marketing hype, and it's also the next wave of IT, but it's also a new way of thinking about IT. And it's like a state of mind. Well, for some reason in Amsterdam, this joke is more funny than anywhere else, but but it's a state of mind, and it's a different kind of thinking around the delivery and development of IT, and I hope to show that to you. And some of the examples will actually touch upon those of the previous slide. So a little bit about me. I wrote my first computer program in 1973. Who wrote a program before that? Say again?
Who was born?
We weren't even born before that. I was hoping somebody would be before that. Okay. So, respect.
How about 5 years later?
Anyway, it was a lot of fun. That machine was probably less powerful than this one. Yeah. Okay, then I did a PhD on protocol stuff. So I was into networks fairly early and into software as well. Then I worked at Bell Labs. I did write a chapter of my PhD, but I think my most important claim to fame was that I was mentioned in the AWK book. Then I went to the Dutch Rail Automation, which was later acquired by EDS. Did a lot of things, internet-related stuff, but one of the more interesting things these days is that back then we had this NS planner. Who remembers the floppy, the big one? Because later they had the small one. And then they turned that into the OV planner, and that was one big monolithic program that was incredibly hard to maintain. One of the projects we did back then was to cut it up into what we now call microservices. Mind you, this was 1995, I think, 3 years after it was started. You know, 92, who remembers the number? You know why it's called 92? It was started in 92, right. Then I went to EUNet, was the height of the internet days. We worked on some network consolidation projects, network services consolidation, really interesting stuff. And then on to consultancy. The CVNet architecture was a really complicated piece of networking. It wasn't so much technically complicated, it was hard to join all those social security institutions together. 10 years later they managed to merge them, but back then there were 5 or 6 of them, and they all had a different opinion on what a service level agreement should look like, or why you should want to have one. Looked at strategic stuff, cost performance analysis, risk assessments, of fairly big things. So kind of moved into digital infrastructures and risk around that. And then 10 years ago, I started as an independent. 5 years ago, I started into cloud training, and there was quite a demand there, and then quickly moved to cloud security training because for some reason the most 3 important topics in cloud back then were security, security, and security. So for some reason that is most of the courses that I do, and I also create some of those courses. And at the end I will tell you what I'm going to do next. So let's get into this, the big picture perspective. When you talk about digital infrastructures and the management of digital infrastructures, there are a couple of very fundamental changes. Fundamental in the sense that they're technically different, but more importantly, they change even the complete power structure around IT, the way we manage IT. And at every phase you have old school thinkers and you have new school thinkers, and they totally don't understand each other. And my perspective, my point is, so who has been through some of these themselves? No? One, if you've been to one. No? Two, if you've been to two. No? Anyone who was four? Yeah, I know you're there. Perhaps.
Yes.
So,
While we're here.
And this is just another one, you know. And yep. As a matter of fact, technical people don't resist change. They're actually capable of doing this all the way down to the next wave. So each of these is a very disruptive change, and I'll explain what disruptive is in a second. But to be successful in that, you have to understand what is really changing and how fundamental the change is. So, mainframe to client server. The IT department was pretty powerful. They were the only people who ever really understood computers. And then power decentralized. And when the internet came, we actually shifted away somewhat the responsibility of the operation to people out there. And then we outsourced data entry to the people who were doing the online shopping. And that has changed a lot of things. Of course, it was a great benefit to companies because they didn't have to buy the computers to do the data entry. You and I were doing that. But it also introduced a new risk. Now we have the cloud, and of course everybody also talks about big data and social and mobile. But really, the fundamental thing is that we've industrialized IT, and I'll get back to that in a second. So what's a disruptive innovation? This is not a hype thing. This is actually something that you can write an MBA thesis on. And there are two types of innovations, like continuous innovations and disruptive innovations. And disruptive innovations start in a funny way because they're like much cheaper than the thing that it replaces, but they're not as good, of course, obviously. But they serve people that really can't afford the original big incumbent solution. And because there's a real market that is served, there's money to invest. And then with any technology, something that you can invest in will improve. And eventually it can actually drive the original out of the market. And this pattern can be seen in a lot of industries. It's not even specific to technology. Examples: mass manufacturing, the PC, that was the interesting one. The first time I saw a PC, I'm guilty as charged. The first time I saw a PC, I was working on this big Unix machine. It was like, you call this a computer, right? Can't even multitask. What do you mean 640K? No, my bootloader was bigger than that, right? So you don't take it seriously. The incumbents don't take it seriously because it's not as good. But it solves a problem of somebody, and then it actually starts growing. So the internet was an example of that. So back in the days when we were doing the Suminet, it was like, the internet, well, yeah, of course, but for real data transmission, you need to buy expensive stuff from KPN. Oh, sorry, wait. Like leased line, 64 kilobit leased line. How much was that back then, internationally? 64K, right? Like nationally, 1,500 guilders. So by now that will be like 2,000 euros. Internationally, maybe 10,000 a month, right? For the price of that leased line, you can have like ADSL for life. So that really, but initially it wasn't as good, the internet. It was crappy. There's this joke about this guy who's in a commercial, and he's speaking Norwegian and playing the guitar. He says, "Wow, thanks to the internet, endless possibilities have arisen. I have learned to speak Norwegian and play guitar all the while I was waiting for the download of my webpage."
That brings back.
Right now, every payment, every PIN transaction is run over the internet. Well, 99% anyway. Wikipedia, another interesting one. So what was the victim of Wikipedia? The Encyclopedia Britannica. It no longer exists. First, at the beginning of Wikipedia, it was like, nah, you can't take this seriously. No, there's no team of real professional English professors, right, doing that. Well, how things have changed. And then cloud computing. A couple of years ago, it was like, no, I mean, it goes down all the time. Yeah. No, that's not a bug, it's a feature, but it's a different story. And right now, it's just become a lot better. And the big driver behind that, I will explain in a different way as well. And then maybe, I don't know, if Docker should be considered as a disruptive innovation. I'm kind of out on that, because what does it replace? in a way that is not as good.
Well, not much actually.
Yeah.
Virtual machines, right. Docker is a kind of lightweight virtual machine. It doesn't have the real isolation features of real virtual machines.
So, yeah, so once you have all these virtual machines in the cloud, what is your use case for Docker?
Well, let's not get into that too much because there's a lot of talk on Docker. I actually have an opinion on that, but maybe it's an example of this. And of course, Docker has its faults and its etc. etc. It's not mature technology. Let's face it. You know.
So it proves your second point. It's not as good.
It's not as good, right? But does it? But does it actually fit the third?
To me, it feels more like a transitive technology.
Well, that's. I mean, looking back, you can say that of all these waves of technology, but.
Yeah, in the way that the fax machine actually.
That one's actually dead now, right? Or is it?
Yes, but it was basically it solved a problem. How do I
It all solves problems.
send images over the phone?
Actually, I don't consider the fax machine a disruptive innovation because it wasn't much cheaper to begin with. It was actually pretty damn expensive. Well, let's not digress.
But it did serve a new need.
That's true. That's true. But that's not the characteristic of a disruptive innovation. Disruptive innovation actually does not so much serve a new need; it serves a new audience for an existing need.
Yeah.
Right. But it's a much bigger audience, and that's the new thing. So it's really more marketing. Let's not get into that. So whenever you have these waves of technology, you go like, hey, you know, I can ignore the PC for a long, long time. I can ignore the internet for a long, long time. But sooner or later, there's a tipping point. And then suddenly, the world looks different on the other side of the tipping point. And then the old school guys they go grumpy, and the new, because they don't feel heard anymore. And the new school guys like, what are these people thinking? Now, fortunately, people can develop. Now, I've been through most of these, and I no longer consider the PC as a worthless piece of junk. At least not most of the time. So there's this big change, and you know, every industry goes through those changes. And I'll show you a non-IT example in a second. But first, like, okay, what's the change in IT? This is like your daddy's data center, and it's like, you know, you see the protective walls, right? And the very thin 64K internet connection. And you know, from a security perspective, because that's what I typically use this picture for, from a security perspective, all your digital data starts its life here, you know, it has its entire life in there, and it ends its life in there. And the only thing that you need to do to protect it is put a big wall around it. Of course, it starts leaking a little bit, but back then that was really the only thing that you needed to do to secure that data. Obviously, the world looks a little bit different these days. Everything is connected, and any piece of data that flows through your system is probably data entered by somebody else outside of your control. And then it gets into your system through some kind of data connection, and then you do stuff with it, and then you send it out to other people outside of your control. So that's a completely different perspective than, hey, I have a big wall, I control everything. So a disruptive change, not only in the technology, but also in the security needs that we have around that. New requirements really around security. Okay, let's get back to the fort. And the previous talk had a fort in it. Now I have a fort that's a little bigger. This is the River Rouge plant. Anybody ever heard of the River Rouge plant? No. Right? It's on the outskirts of Detroit, where Motor Town it was called. And a lot of people work there. And then in their spare time they listen to Motown records. Remember that? And the River Rouge plant was built starting around 1918, and this is where the T-Fort was built for the T-Fort to begin with. And back in the days, it was a completely integrated factory. As you can see here, this is the River Rouge harbor. This is where they put in the iron ore, put it in the steel mills, and then it would go around that entire about 2 square kilometer area, and on the other end, out came T-Forts. Right? And it was all integrated and all owned by Henry Ford. The Henry Ford Motor Company, that is. I think they had this integrated model of production all the way to the Ford Mustang late 60s. The plant is still there. The area is still there. But by now it has been totally split up into a ton of different companies. The steel mill is sold off, the electricity plant is sold off, the glass factory is sold off. It's still there, but it's part of an entire automobile supply chain. Just the size of this, let's see, this yellow dot is a railway engine. So it is really 2 square kilometers or something. It's really pretty big. And the car manufacturing industry, like a lot of other industries, have developed from being an integrated industry, where Henry Ford owned it all, from the iron ore all the way down to even some of the dealers, into a lot of small individual companies. Now last year I was doing a class security training in Tunisia, of all places, and I, of course, nothing to do there. So at night I had my dinner, and there was a guy who looked like an American. I was having a burger and a Coke, so that was why I assumed he was American. He was sitting there on his own, so I chatted up a bit with him, and then he said, "Oh, I don't speak much English because I'm actually German." Well, later on. And he was there. I said, "Why are you here?" "Okay, so, yeah, I'm actually here because I need to audit a part of the supply chain of a big German car manufacturer. I can tell you which one, but it would distract from the story." So I said, "Okay, well, what do they do here?" "Well, they this factory here makes the part of the electrical system of the car." I say, "Oh, the cable tree," whatever it's called in English. No, that's way too complicated. What they make is the piece of wiring that connects the battery to the body of the car. That's the only thing they make, right? And then they ship it to whatever, Wolfsburg or something. And so I was, hey, that's interesting. That's interesting. I've been hearing these stories about the car supply chain. Tell me all about it. And he was actually confirming all those stories. You know how much of the value of a car is actually, produced by the car manufacturer, and which part is actually purchased? What that ratio is?
80%.
80% is purchased, right? So only 20% is the value that the car manufacturer adds.
Just assembling.
Was that again?
Assembling the car. Just assembling the car instead of...
Yeah, basically. Putting the logo on.
Branding.
It's the same with
Putting the software in.
It's the same with the Apple iPhone. No, I just read up on Steve Jobs' biography, and the early Macs, they were really built in California. But Tim Cook actually changed a lot of that and outsourced it all to special manufacturers. So any maturing industry has this tendency to split up into a long supply chain of highly specialized factories or manufacturers or service providers or whatever, doing a very specific job. And why can they do that? Well, because you know what they need to do, and you can control that quality, and they actually can deliver that quality. The German guy said, well, there are these, I would call them service level agreements, and they would tell a company like, okay, if you don't deliver before tomorrow 1 in the afternoon, the supply chain will stop and you will get a fine. And they can actually, most of the time, deliver to that. So that some of these companies actually resort to flying helicopters to get the parts in on the right time to live up to their promises. The point is they can. Back in the early days of Ford, nobody knew how to produce electricity on the scale and on the quality that Ford, or steel for that matter, that he needed. So he had to own it. So that whole supply chain is fragmented into a lot of different parts, and each of these parts can then optimize, can then innovate, and be smart about it. And as a result, the car supply chain, even though it's really, really complicated, now produces cars that are much better than the T-Ford, much more functionality, less emission of whatever toxic stuff you have, more colors, right? More than one color, right? And a lot more functionality at a lower price. Because we have the entire supply chain has been cut up into pieces that can then each innovate themselves and reduce the cost and improve that. And the guy was also saying, well, yeah, the head office, they're thinking about, okay, this problem occurs in 1 in a million cars. Shall we fix it in the production, or shall we fix it in delivery, or once the car is on the road? And they call that a versteckte rückruf, so it's a hidden recall. So the car goes to the regular dealer and they just fix the problem and they never tell the client about it. And they make these decisions on 1 in a million cases. So that's a level of quality control that is in that supply chain. Now, what does it take to do that? Now, here's a simplistic perspective of that supply chain. But if you study supply chain, manufacturing, and all that stuff, modern manufacturing, then you see that there's a lot of principles in there that are, in a way, counterintuitive. For example, in this incredibly long and complicated supply chain, where you have a really dependency on all these suppliers, don't keep stock. Now, that sounds like a risk, and it is, because if you run out of stock, the entire supply chain will stop. That's bad, isn't it?
Actually, it did happen a few weeks ago before.
It happens, shit happens. But the alternative is actually worse. Because if you load up your supply chain with supplies if your manufacturing chain with supplies all the way down, you have a lot of inventory that is taking a lot of capital. And by the time you find a problem here, and you trace it back to one of the original inputs, you fix it, it's going to take a year for that problem to be solved, to be visible to the end user. And the lower your supplies, the lower your work in progress, the less waste you have. So it's a trade-off.
So basically, you do it just in time.
It's just in time is one of the principles that gets to that. Now, my point is that there's a parallel between this and the way we run IT, and that actually is, I think, the essence of what we see in the cloud computing revolution. Here's a simple supply chain for IT. Modern cloud computing supply chain. We have your customers on the right, like your big companies or less than medium-sized companies, and they tend to consume a lot of SaaS. Now, of course, they also have their own applications, but that's a matter of time before they sort of get moved into the cloud. There will be just a fraction will be their own applications. I have a different story on that. So the average company has like hundreds of SaaS applications. I know, I get these people in my cloud security training, and I always ask, how many SaaS applications do you have? 3 years ago, was a guy from an insurance company. Yeah, I asked the procurement department how many cloud services we were using 3-4 years ago, and they said 200. That was 3 years ago. Financial industry, and those were the ones that they knew about, right? That procurement actually knew about. So this is real, this is happening. But any realistic SaaS provider doesn't run their own kit. If they do, they're basically stupid for a number of reasons. And it's the same, one of the reasons is the same reason that Henry Ford no longer has a steel mill. Somebody else can do it better, cheaper, more reliable, etc., etc. If only you know what to ask. Back in the days of Henry Ford, they really didn't know much about the quality of steel. So it was like, yeah, it feels like kind of good. Maybe you can fix it a little bit like that. Right now it's like, okay, we want this quality, and here are the details of that. And I can tell immediately when you deliver that or not, as the case may be. Now obviously, the reality is a little bit more complicated. This is more like a realistic supply chain. And in a way, this actually adds to the point, because in this ecosystem in the middle, you have all these specialized vendors, all these specialized, they focus on one particular job. Maybe should have thought of a better example, but anything like from datacenter to whatever API for a specific security reputation service, hundreds of them. And then you can become really good. And if you're in a big company, you can't make 100 services good. You can make like 10 good and the 90 are mediocre. Then a couple really suck. And the cloud model allows us to have this creativity, this ingenuity, this innovation on each component in a way that is actually it's more like a market economy, and this is an example where market economy actually brings out the best of innovation. I'm not necessarily a fan of the market economy in everything, but this is where it works. So much for like the supply chain. Now let's move to speed, because as we saw in the earlier story, that the speed with which we can change that supply chain is, let's say, inversely proportional to the amount of stock that you have in between. So the faster you can drive through that chain, the more agile you will be. And here's another, that was more like a zooming in on a specific, or actually two specific innovations. This is like a slide from Adrian Cockcroft, brilliant guy by the way. He used to be the CTO of Netflix. These guys were really pioneering microservices and continuous delivery and all that stuff on an immense scale. The first couple of years they did that, everybody said, like, no, you cannot do this, you're totally crazy. Probably they still are, but they were still successful with that. And if you see what's going on, you see, like, okay, back in the days of the data center snowflakes, actually it was way after the mainframe, we're deploying individual servers here, and they're alive for years, and it takes a couple of months for them to come online. So how long does it, in your memory, does it take between when you order a server and when you can actually put it in production?
A few minutes.
Yeah, that's right now, but like 5 years ago.
6 to 8 months.
6 to 8 months, right? So if you run a test, you better have all that kit in place before you start your development. So virtualization actually makes it possible to do that in minutes, except for the red tape, of course, which turns it back into 3 weeks. But even virtual servers have their starting up time. You know, if you boot a virtual server, it takes a couple of 2-3 minutes, depending on the platform. Windows is a little longer. Maybe you can speed it up beyond that. You go like Docker containers, but they spin up in seconds, depending, of course, on where your registry is. And beyond that, we'll have stuff like AWS Lambda, which is the future. And this is life beyond Docker. Last Monday there was a presentation on serverless architectures. Well, but it's a little bit too much to stomach for the average company. So this is the technology that drives that's speeding up that supply chain, and you can push that change through the supply chain really quickly. Any questions on this? Any objections?
Well, if you look at the
Any
bigger
light bulbs,
companies
yeah.
like Google or Facebook, they're owning the whole supply chain, right?
No. Well, yeah. That's an interesting case. Yeah. But at the same time, if you look at how they're organized internally, it's different. Well, we'll get to that when the next slide is a bit of a repetition from the previous one. Now we're talking about how 90% of the companies is working. Yeah, and I know Amazon actually rewrites the firmware of their SSDs, right? I know, Werner told me, right? And so you could say, well, they're sucking up that part of the supply
They're
chain.
creating their own languages. So.
Oh yeah, like yeah, some of them do, yeah. So that's re-aggregation in a way, but that's not the norm. 99.9% of businesses are not like Google or Facebook. The problem with those top 5 providers is there's only 5 of them, right? And the rest of the world has to use whatever they leave for us. Right? So this story is similar to the KPN story. How does code get into production? I'm painting the continuous delivery picture here, which is pretty new. I mean, it's like just a couple of years that we're doing this. So all software starts as like a source code, you put it in a repository, there's some external stuff, trusted base OS, and then you build it. And in the build process you do some testing, static, dynamic, security. And we'll get back to that in a second. And then you have some kind of golden image, and depending on your architecture, depending on your language, depending on a lot of things, there's a lot of variation in this process. But this is a high level perspective. And there's an orchestrator actually puts it to production, that does some runtime checks there as well. And then depending on the load, we need more of this. And it's all automatic. That's the whole idea. And I want to get back to this when we talk about security and risk management in general. How are we doing in time? Another 20 minutes, right? 20 minutes? Is that okay with you? 15 minutes? No, you just stop. That's okay. So, and then this creates feature velocity. And feature velocity, you can define as the number of deployments that you do per day. Now, I'm not making up these numbers. These are real numbers according to that book, of course. Anybody read the book, Phoenix Project? If you haven't, do. Right? It's a great book. It has everything, including the entire story on how you're doing exactly the same thing in software as you were doing in the supply chain, manufacturing supply chain, down to the gory detail. Now, if you're cheap, you can get a excerpt of this, which is like 1/3 of the size, free on the internet. But I suggest you divide the book. It's like a novel. It's really fun to read. First, like when you're halfway in the book, you go like, "Oh my God, I've been there. All these death marches, these all-nighters." You read it, right? I can tell by your face. You go like, "Oh my God, what are these guys thinking?" And but then they move it around, and it more kind of like gets like this. And the interesting thing is that this does wonders in your supply chain if you do it right, of course, because it is actually pretty complicated to pull off. Henry Ford had to have the entire supply chain under one command because he couldn't rely on any contracts or subcontractors because basically there weren't any. Right now in the car supply chain, you actually know exactly where the problem is, and you have an alternative supplier basically for everything as well. And you can do that, which means that the velocity in the supply chain, the amount of change that you can have there, and if you want to build on demand, you can do that in that entire supply chain because you don't have a big stock in between. So that's an important thing. And the funny thing is that the higher your deployment frequency, the lower your risk of each individual deployment. So on the basis of that alone, your quality increases. A couple of years ago, I was working as a consultant with a company who were producing a cloud solution for municipalities, gemeentes. So some basic stuff there, like 1/3 of the municipalities in this country was their customer. One of the reasons that they found there was an appeal in the cloud solution was that these IT guys at your average municipality had this like, "Oh, we have to upgrade this every year. There's a new version every year." Oh, there's a lot of, there's a change, right? That's scary. Well, let's skip one, right? And then the year after that, the problem gets even worse, right? Because nothing really remains the same when you upgrade that. It's going to be one big nightmare, and exactly like the one that's presented in the Phoenix project.
If it hurts, do it more often. I often hear this expressed that if it hurts, do it more often.
Right, and make the steps smaller. So on that basis alone, it pays to be able to do this. Now, there are a couple of, let's say, assumptions that are challenged, and not everybody is happy with that challenge. So your old school auditor will have a bit of a shock there. And I actually had these people in my cloud security training, like, we came in, that provider, you mentioned in the course, I can't tell its name, I think it was PayPal, and and they were going to audit all their systems, and they were like, with their old school approaches, and they were like day two, they were laughed away, like in these restaurants when you have these steel burrs and then tar and feathers, and who reads Lucky Luke these days, right? But they were laughed out of the building because they were saying like, "What are you testing in production? Whoa, that's a big no, right?" Or "Tell me how you patch servers." No, we don't. What's your process for patching servers? Well, we don't have any, right? Big no. Whoa, these guys are mature. Or what do you mean? Where's the meeting? Your change advisory board actually is to ask you, what is CAB? Like, change advisory board. Yeah. No weekly meetings? No. It's too much red tape. So these auditors go like, "Oh my God, this is so bad." But then, I'll tell you later what the real situation is. Okay, so now I've told you about the supply chain and all this, a lot of moving parts, right? I told you that a car these days is like 20 times more complex than the T-Ford. The same is true for software. If you see the amount of software that's being built into the tiniest product. Now, I remember the days when most of the world's open source software fit on a reel of tape, right? Boy, that's a long time ago. So there's all these moving parts. features with velocities like 23,000 updates a day. Feels like young small kids playing with sharp knives. So what do we do there? Now, and from my perspective, I'm not a much of a security person. I'm a risk management person, and not even that. But that's just the perspective I've learned to take. Because security is a special case of risk management, and I'll tell you about the risks in more detail. So one of the things that is kind of like a side job to me is that I work with the Cloud Security Alliance, which is a non-profit collecting best practices around cloud security. I run their flagship training for a lot of people, and every year they bring out a list of threats, and this is a really good start for any threat modeling exercise. So what is really the threat? Because if you listen to security guys, they go cry wolf all the time. Like, no, you can't do that because there may be a bug and then somebody may take over the kernel, and then maybe you will have a problem. What's the real problem here? Well, this is what they find out through research. And this is what's called the Treacherous 12. A couple of years ago was the Notorious 9, so apparently something is getting worse. And it's a list of things that are, let's say, considered to be the most prominent threats around cloud security in general. You can download this as I think it's a 30-page PDF, and it has all these detailed out, as well as examples and controls, etc., etc. And if you find that too much, then basically hire me, I'll run you through it. I won't go in a lot of detail through all these because I have a couple of more nice pictures to show. But it gives you an idea of how you can approach this. Okay, this is threat modeling. First, think about what is really your threat. Now, it depends on your organization, of course. You may have different threats, and as a matter of fact, I'll show you a couple of things that are not included in this and are still relevant. So for continuous delivery, I ran a Docker risk management workshop in the spring, and we talked to a lot of people, even practitioners working at Eijk Bank, although they weren't allowed to say that. And in that risk analysis, what kept up as the biggest asset at risk in that environment is your feature velocity. If you have feature velocity, you can basically solve every problem. And if you don't have feature velocity, you have a lot of other problems to solve as well. Small example, suppose you have a component that has a bug, a security vulnerability. Now, old school, what you needed to do was, okay, wait for the next release cycle or bring out a hotfix. Both of them are very risky things to do. Right? If you have feature velocity, you basically push the button, push it through, and done. Who remembers the what was it? OpenSSL.
Which one?
Heartbleed. Yeah, which one? Yeah. So there were a couple of some of the Dutch municipalities were like 5 months offline because of that, or because of the collateral damage of that. Other companies having a CD pipeline, basically like, oh, new version, push the button, 30 minutes later everything was patched. So if you have the feature velocity, it actually solves a lot of other problems. And it is, in a way, from this perspective, the biggest asset that is at risk and that you should protect. So part of that is software supply chain security. Now, if you're dependent on that, then go into that. Who is the master account to your GitHub projects? Just a random question. Now, the nice thing about GitHub is that you can't. It's like Hotel California. You can try and exit that, but try and get rid of a credential that you put in there. It will be versioned and it will be there forever. Right? So that's the easy bit. But there's a couple of other. Who owns your Amazon master account? Who has that? And who uses that on a daily basis? Okay, fire in. So components, the provenance, where does it come from? Who has access to it? And in a way, that software supply chain is your production. It's more important than the client's production system. It's not like, no, that's just development side, not as important as production. No, for you it's the other way around if you're a developer. If you screw up this, then you lose the top asset for you. So that's a perspective that I give for you. And then another thing that you want for continuous delivery is a scalable and resilient deployment environment. But I guess you know all about that. I'll just zip by a couple of slides in a second. Now, if you're agile, one way to approach it is use user stories, which everybody uses in agile, don't they? And use them for security as well. And here's two nice examples I found. So here's like a positive user story. As a security analyst, you want specific functionality to help prevent certain risks. And here's an example, like rate limiting. Now rate limiting is so essential. If you can't do that, and you're out in the wild open, then basically you're exposing yourself. Another is what's called the abuser stories, like this is what the hacker wants. And write them down. Don't go like, yeah, there's a risk that somebody might hack it. No, run the specific story and the way they do it. Because otherwise you're not credible with the rest of your team. And if you want to have this more specific drill down into this, there's a great presentation by a guy who was at the NSA, and it's on my blog as well. What's the name? Anyone see that? The NSA guide explaining how they would hack your systems and their methods of operation. And it's pretty neat. And they don't need 0 days. Right? They don't just need patience. Right? And if you drill down into each of their attack vectors, you can specifically protect against them. Not to protect you against the NSA, but to protect you against organizations like the NSA. Right, so more threat modeling. So how do you tackle security in this cloud world? And I'm writing down cloud security here, but it's basically, as you will agree with me right now, this is about the supply chain thinking, where you outsource stuff. And this is what enables continuous integration, continuous delivery. Can you imagine doing continuous integration and continuous delivery without infrastructure as a service? On-demand spinning up of instances can't be done. I mean, you don't have midgets fast enough to boot up those machines and put in the CDs. It doesn't work. You really need that automatic self-service provisioning for continuous integration and continuous delivery to work. So, I could run down this, but just highlighting. So there's I'm using 5 perspectives to look at security. Historically, we only had this big wall around our data center as our #1 control. And instead of ownership, where we say, hey, we own it, so we control it. Actually, not so true these days. You want to have explicit controls to your provider. Say, I want you to do this. I want you to make sure that my VM that my hypervisor is patched. I want you to do this. And the provider will promise you that. And if they don't, they shouldn't be your provider. What you also have is hyper-segregation and automated deployment. Now, automated deployment is something that is CD style, but hyper-segregation is we don't have one firewall, we have a firewall for every machine. And the same principle applies as with the velocity change. Who's ever did a firewall change in a medium-sized to large-sized company? How long did that take?
I'm still waiting.
Right? Now, it's almost embarrassing, but I once made so much money as a consultant on one single firewall change that I could buy a small car for that. It's like 2 lines, and it was like 5 months of frustration. And what's the reason for that? Well, because, and as you know, how big was the rule set of that firewall?
It was 1 port on 1 IP address.
Yeah, sure, but that was what you wanted.
Yeah.
But what's the entire rule set in which that was a change?
I have no clue.
Probably likely to be thousands of rules.
Yeah.
So by the time you have thousands of rules in a firewall that nobody really understands, you go like, hey, what happens if we tweak this one? Well, I don't know. And if I don't know, I'm not going to do it. Right. So you get the same problem, like accumulating changes that will become too big.
It's not about the size of the needle, it's the size of the haystack.
Yeah, finding the needles in the haystack is always hard. That's it. Anyway, so hypersegregation really turns that around because you make firewalls that have like 4 rules, right? And they're independent of one another. And you generate them automatically as part of your CD pipeline. Okay, I'm going to skip all the other ones in some more detail, but you get the idea, I suppose. Now, what's scalable infrastructure? I think you know about this. You know, load level automatic provisioning, failover, the whole shebang. Google has it, Amazon has it, everybody has it. And the key thing to do, you know, and this is again back to the process perspective: automate, automate, automate. And it's not so much because of the efficiency of the process, but the repeatability of the process. So what's the famous line here that the picture points at? What does it look like?
Cutting edges.
Yeah, cutting edges. Yeah, what is cutting? Toast. So the expression is, don't scrape burnt toast. Don't fix the toaster, don't fix the toast. And this you know, the guy I met in Tunisia, the German guy, he said, actually, I don't even look at the product in the whole factory. I walk through the factory and I have a nose to see where the process isn't being adhered to. Because if the process is good, the end result will be good. Now some of you might object that, but there's some truth to that. And it does scale. This is an approach that scales. And that's, I think, the biggest point. Now this is what all of continuous delivery and continuous integration is about. By automating, you make it more repeatable. You make it more auditable, which is interesting if you have some risk management and compliance to do. So, no, I'm not, let's say, objecting whatever everybody has told you in this meetup. I'm just giving you the background why this is so. It's a process perspective that is like, this is like Six Sigma principles. If you want like 100 million lines of code to work with not too many bugs, then you have to have this kind of process. You can't rely on superhero programmers. Okay, what else? Okay, let's go to some more controls, and now we're nearing the end. If you really want to deep dive into this, then there's a pretty good book by Jim Bird. I think it's a free download as well. DevOps, he calls it. I think it might better be called DevSecOps, but that's a point of opinion. And here's one model that he gives. So this is like an abstraction of that CD pipeline, really, with all the steps in there. And each of these steps is, let's see if this one works. It actually works today. And there are some specific controls related to specific steps that you can apply here. Now, of course, this is a big story, but this, I hope to show you that some of these controls are actually better than what we used to do. Some of you, it looks familiar to some of you, right? Who has seen this before? No? Okay. Then consider this as the contribution of my presentation. So a couple of things, static testing in your IDE, automated unit testing, this is what we have seen already, digitally signing artifacts, making sure that configuration is in secure infrastructure as code, version it, you know, it's like, don't ever touch a command line in a server, you know, use an Ansible or a Chef script. As a matter of fact, I was told by, I think it was Adrian Cockcroft again, that at one point in time they just disabled the shell daemon on their production servers. Just disabled it, so there was no way that you could log into them. Now that definitely prevents changes, I say.
Yes. No longer can use Ansible.
Well, you can't even use Ansible then anymore, right? No, but that's a different story. Chaos monkeys, who knows about the Chaos monkey?
Netflix.
Yeah, Netflix, right.
Similar.
Not everybody?
No.
So what does the Chaos monkey do?
It basically
Kills random things, right?
yes. At actually very well defined points of time during business hours while the whole team is around to monitor what happens instead of having it happening randomly somewhere in the night when no one's
Yeah. Wait, break it. Now, one way of looking at it is from a process control perspective. You want to test the resilience of your application, right? And there's no other way to test production than in production. Now, of course, Amazon was creating errors of themselves, but apparently, in the thinking of Netflix, Amazon was not creating enough errors for them to have any useful test results. So they had to raise the basic level of insecurity, and that's where the Chaos monkey comes in. It kills random stuff in production. Now, go tell that to an old school auditor.
Kills gorilla?
Yeah, that's a variation of that, isn't it?
Kills data centers?
Kills entire data centers, right. They have this for the main application. They actually have the application is load balanced across 3 data centers, across 3 availability zones in 3 different regions. So if like Europe goes out, there's still 2 sides of the US that might actually serve Europe then again.
Tell that to Azure today.
Tell that to Azure. Yeah, Azure. Right. Well, they're working on it. I suppose. Oh, Amazon actually doesn't even do that for you. You have to work on top of Amazon to make that happen. Now, funnily enough, Amazon actually has a distributed management plane. So if you can see that from the management URLs. They're different per data center. Apparently, Azure has a single management plane that controls all data centers. Now, if that one goes out, hey, there's your single point of failure. So by now, you can guess the answers here. So testing in production, yeah, but basically mainly for performance and A/B testing, or red, green, or blue, green, whatever. And we can roll back in just like that. And in less downtime than our SLA allows, we can roll back. No patching of servers. Well, you know that you already gave it away, the cattle versus pet. Yeah? Our server are not pets, and if a pet is ill, you bring it to the veterinarian. No, you're merciless. You go, it's ill, we kill it. Right? Terminate with extreme prejudice. Which movie was that?
Old Yeller?
No, Apocalypse Now. You can try again. And then no weekly CAP meetings? No, because every decision that we took in that change advisory board, we actually implemented in software and in our build server. And if that policy is violated, it doesn't even go to production. Of course, then it can get killed by the chaos monkey, but that's a different story. So this is the answer to the old school auditor. And by the time, I have people in my classes, by the time they understand this, they go like, yeah, it's definitely a new world out there. And they start using that kind of thinking to really re-engineer that entire value delivery chain. And that's what it is. It's industrializing IT production. It is, and in a way it's also democratizing this, because we can now run this for like $30 a month, right? If you want, you can set up a CD pipeline for less than that, if you want. Of course, it doesn't scale very well to 100 developers, but that's a different story. But it does scale to 1 million hits per minute, which is what counts to a lot of people. So this is the new world in a way, and it's a more professional world, one way or another. It's a world with a lot more governance and control and compliance. We can hate that. We can also see that as an enabler of a world in which we can attain a much higher feature velocity and actually have the business no longer wait for IT, but more like IT wait for, okay, you come up with a nice idea, now it's your turn, right? And this actually happens in large companies that employ these processes. These suddenly go like, hey, we have time to spare as IT, because we've killed the entire business backlog. Now we're on top of the game, and this is, we see what some companies in this country and elsewhere are doing. It is freaking amazing. ING is telling this story everywhere. Now apparently only 1/10 of that is true, but still, even if 1/10 of that is true, it's still impressive. So that's my story. I don't really want to focus on ING myself. ING is a much bigger meat to kill. I want to focus a little bit on smaller companies, and if you're interested in that, then I have some small tips for you to get started. You scan the code, fill in the form, and I'll send you some. I'm building this out so that you can start apply this in small steps, and not by hiring 10 consultants and wait for half a year or longer. But really, if you're a company that has like 10, 20 people, or a team that has 10, 20 people, you can't afford to do the full work. You have to start with baby steps. And if you can't catch it this quick, I'll give you a brief note. So that's the same information on that.
Maybe you can provide a link to the presentation.
Yeah, I will do that.
I found a lot of interesting stuff that I want to follow.
What was that again?
There's a lot of interesting stuff in there that I want to follow up.
Okay. Well,
not just
I take that as a compliment. Any other compliment? I'm sorry. Any other questions?
More of a comment actually. About 20 slides back.
Yeah. In the bottom left corner, there was a small mistake.
The whole slide. The platform as a service, and infrastructure as a service.
Yeah.
And I think a good example is Salesforce.
Yeah.
So until recently, they were so big and enormous, the biggest software as a service supplier in the world.
Yeah.
And they obviously had to run their own stuff. They had to have their own steel plant, their own glass plant,
Yeah.
their own rubber factory. And now they're moving over to Amazon.
Right. Yeah. But the inverse actions are also happening.
Yeah, I think and Dropbox is moved away from Amazon, I think, with run storage.
There's no, but that's I mean, right now. Only very special cases you don't want to run on somebody else's infrastructure.
But the interesting part is that it happens in both directions, which is exactly a good point in having all these separate services from, you can actually change.
You can actually change. Yeah.
Instead
I mean,
of having to go yourself.
the interfaces are reasonably well defined to allow you to change. I mean, if you run like an electricity plant that has a specific specifications like it runs on like 40 volts or 800 volts rather than 400 volts, which is normal for industrial electricity, then you can't change. It's that standardization that also enables innovation in a pretty paradoxical way. This is also one of the reasons why in the Docker ecosystem, because you're raising the level of standards, you're getting stuff that solves problems in generic ways. And that wasn't possible before. It was just to spread out. Like DICE is an example of that. The Kubernetes is also in that space where you're solving problems that before that time there was not enough scale to do that. So you had to handcraft it. And now you can have these services or these software solutions, whatever, that do that for you. And that again increases the speed of innovation. I think that the biggest lesson here is that it's innovate or die. We know that. So if you want to stay ahead, don't fight. Don't fix yesterday's problem with yesterday's technology. Fix yesterday's problems with tomorrow's technology, because it will catch up. Thanks. Any other questions, comments? I'll stick around for a few more drinks, so no rush here. No further questions? Well, okay, 10 to 9. Just what I promised.